go.
All right, for the people coming in here, later on there'll be a competition, and on your phone you guys can log in to Kahoot. I guess you could do it on your computer too, and you can put that pin in, and you can be part of the competition later. There'll be no prizes except for fame and glory.
Fame and glory and gloating.
You get to see your name on the screen. Look at all these people.
I know, it's so exciting. Some of these names I remember from JOLT the last couple of years.
So many people I know.
Awesome. We'll get started here in just a few minutes. We want to give folks a chance to log in. As Nick said, go ahead and join us at kahoot.it. Use that game pin to sign in. It'll ask for your name. Your name will be added to this little scoreboard. There will be a quiz. This is an interactive JOLTed session. And so we want all the participation. So go ahead and go to kahoot.it, register your name with that game pin, and there'll be a quiz towards the end to see what you learned.
Unless your name is Tommy Haycraft or Ben Allen, then you're not allowed to participate.
I see Tommy on there.
And Ben.
Yeah.
Oh, which one's Ben?
He's Ben.
Just Ben.
He's at the top. I was Tommy on Cahoots. Is that what you're saying?
Oh, yeah.
Oh, there he is, T-Maxer. You're disqualified, Tommy. You're a game master. Come on, man.
Well, now he has to defend his honor.
Let's see, Chuck Gardner all the way from the great state of Louisiana.
Nice.
We have foreigners in here.
We're starting to get registered. Awesome, awesome. Again, if you're just joining, go ahead and join us on kahoot.it. Use that game pin to log in, and there'll be a quiz. Nick, the instructor, will quiz you at the end to see what you've learned.
And also, if you guys have not yet joined the Discord, please do that as well. This is going to be our communications platform going forward with Jolt. We do want to keep that going throughout Jolts, not just during the time frame like we did with Slack. We're a little bit more flexible with Discord, and so we want to build that community up around Jolt so that people can continue to stay in touch outside of that and help Nick troubleshoot his cat errors.
Yes, the Discord link.
You got that, Ashley?
I can do that. Yeah, I also have it in my slide deck, so we'll refer to it a few times.
Okay. I'll drop it in the chat. If you guys
okay, cool. We'll give folks another few minutes to log in, sign on, get comfortable, grab a Red Bull.
A Dr. Pepper.
or water, whatever floats your boat.
Not too much, or it will float your boat.
Yes. Also, while we're waiting, I'm going to go ahead and launch this poll. Again, we want this to be an interactive session. You've got your login to Kahoot for this quiz that we're going to take at the end. But also, just for our own knowledge, we want to see if you've participated in a previous Jolt. So if you have, just check the box yes. If you haven't, check the box no. Let us know. Awesome. So far, it's about half and half.
Teetering there. It's all good.
That's really that's a surprising distribution to me, half and half.
It is. So far, we're at 48
Well,
yes, 52
Like it's
no.
random.
welcome. This is not going to be anything like Jolt.
Yeah.
Don't say that.
I mean, yeah, this will help you prepare for Jolt.
Absolutely.
Yeah, we're
We'll
even.
give folks a few more, maybe another minute or so to join, and then I'll kick it off and we'll jump into this thing. Hope everybody's doing well.
Man.
Wish we could see your faces. It's weird speaking
Agreed.
without seeing the faces.
Agreed.
Yeah, we're still at about half, 48 yes, 52 no. So I'll let you guys, when we get to that point, explain a little bit about Jolt and what they've missed in the past and what we can look forward to, fingers crossed, in 2021.
Yay. Yeah. That's what I'm here for.
Yes. All right. One last call. If you haven't, go ahead and use that kahoot.it, log in there, use the game pin, create your username. We'll do the quiz at the end, but also there's a poll just for our knowledge to see if you've participated in a previous JOLT cyber competition. All right, I'm gonna go ahead and end that poll.
Yeah, pretty close to even.
Yeah.
Yeah, 17 of you guys have participated before and 18 haven't.
Mm-hmm.
Which is good. We wanted to draw people in who may have been a little nervous about it.
Mm-hmm. That's exactly what these 4 sessions are about. All right, I'm gonna go ahead and jump in to this session. Hello, everybody. Welcome to the first session of JOLTed or JOLT.ed, whatever you want to call it. This is going to be a great session for you today. We took that poll at the beginning and it showed us that some of you participated in JOLT, the cyber competition, and some of you haven't. I'll let Chris and Nick explain a little bit more about JOLT. Typically, that's a cyber competition that happens this time of year. It's typically in person. We have about 200 people show up. You form teams of 4. The game masters create these puzzles that you complete, and it's this fun competition that happens over a weekend. Again, lots and lots of fun, but unfortunately, you know, COVID happened and we were unable to do that. So the game masters and the Venture Center team created the very next best thing, which is JOLTed, which is what we're hoping to be the educational component of the JOLT cyber competition. Really focuses on the different components of the JOLT competition, but also these are tips, tricks, and tools that you will be able to use in your, you know, high school classes, college classes, and even on into your professional career. So thank you so much for joining us today for this first session on encoding and ciphers. We've got Chris Wright, who's going to moderate today's session. He's the co-founder and partner at Sullivan Wright Technologies. He's also a 4-time over game master, so he knows what he's talking about. We've also got Nick Seward, a computer science instructor at ASMSA. He's going to present to you today on this encoding and encryption and ciphers. He's also been a game master 3 times. So we're excited to have them both with us to talk about this topic. A little bit more about JOLTed. You've clearly made your way to this first session, so thank you for being here. There are 3 other sessions that follow this one. We've got another one on October 16th, all about hacking puzzles. We've got several other game masters that'll participate in that one. October 16th, that's a Friday from 11 to 1, so changing up the time a little bit. Then the 3rd one is web vulnerabilities. That's on October 22nd, Thursday, back to that 5:30 to 7:30 time frame, and then the reverse engineering on October 30th at 11 to 1. So we've changed up the time, hopefully give you the opportunity to participate in these. Even if you're not able to physically participate, we encourage you to register for all of these, because those who register get the recordings of all of these sessions as well. So be sure to register for those, and they'll go into more detail towards the end of this as well. Some of you mentioned this Discord link. I wanted to drop it here in this slide deck so you're aware of that. And so this is the link that you can use to continue the conversation and join us over on Discord. and chat with the game masters, chat with other folks that are part of this, and really help us build that community. That way, when we launch JOLT next year, fingers crossed, in the spring, we've got this awesome JOLT community that we can work with and bolster and support. So use that Discord link to join our JOLT channel. And one last thing I want to bring your attention to, none of this would be possible without these awesome sponsors. So I just wanted to, again, bring your attention to that. We've got Wright Lindsay Jennings, Frost, Simmons Bank, the Little Rock Regional Chamber, Euronet Worldwide, Mainstream Technologies, and First Orion. So big thank you to these sponsors. Quiet round of applause to all of them for supporting this program and letting us bring this to you in these 4 sessions. So with that, I'm going to go ahead and turn it over to Chris Wright, who will moderate today's session.
Thanks, Ashley. So welcome to everybody. As I'm scrolling down the attendees list, I recognize most people's names on there, which is good. It just speaks to the caliber of the community here that we have in Arkansas and even in Louisiana with Chuck there, and also in Northwest Arkansas, because I saw Chris Barnell on there as well. Thanks guys and ladies for coming. If you've been to JOLT before, this may seem a little weird, but as Ashley mentioned, we're trying to keep things alive. We're trying to kind of fill some questions or some requests that we've had in the past. We've always had in our questionnaires, what would make JOLT better? And one of the major things that gets asked every time is, can you provide us with some educational parts to this? And when the game masters come together, we try to integrate educational parts into the puzzles themselves, but no matter what we do, we keep getting asked for more and more and more. So with all the negative stuff that JOLT has kind of forced us into, it's also afforded us this opportunity to split out JOLT into 2 different parts. Normally October in Arkansas is Techtober, and we kind of envision this being part of Little Rock Tech Fest. As Little Rock Tech Fest grows, JOLT and Little Rock Tech Fest work together pretty closely. We go through a lot of the planning together, and we're in tight communications every year. So this is going to be integrated into Little Rock Tech Fest in fall of 2021. But since we've grown massively in JOLT over the last several years, we've struggled to find a place for it during Techtober, because there's so many other events at that time frame. And that's a big thank you to people like John Chamberlain, who really champion the Techtober kind of program throughout the month, but it pushes us into having to find something else. So for those who have done JOLT, just remember that we're going to be shifting to more of the educational side in the fall, but we're going to have the full up JOLT competition back in the spring like we've had before. So don't think you're going to get away from my wonderful playlist of lovely tunes. So don't let that stop you from signing up for the spring upcoming JOLT, because I've been my Spotify account has been taken away. For those of you who haven't come to JOLT, for those 51% of you who haven't, thank you for being here. I know it's a little bit daunting to sign up for something like this without really having a knowledge of what it is. From personal experience, before I started as a game master, I was managing a group at FIS in information security, and a couple of us saw this, I think the second JOLT, and we thought, let's go try to do this, but it had to be teams of 4. And we couldn't talk any of our other team members into doing it because everybody was a little nervous, didn't want to be showed up, didn't want to be, come in blind and really feel like they'd failed at it. So what we hope this does as well is give you sort of an introduction to what that JOLT cyber capture the flag is. And just to kind of run down real quick, that's a cyber themed capture the flag which is a kind of a Jeopardy style puzzle is what we call it. It doesn't look exactly like Jeopardy, but you have a scoreboard and you have puzzles on there, and each of those puzzles will be given a certain number of points if you can solve that puzzle. And you solve that puzzle by reading the clues off the scoreboard and capturing a flag. So you get some sort of text string or something that you would come back from hacking a system or decoding some code or breaking a cipher or reverse engineering something, or solving a physical puzzle, or catching some weird thing like, say, Morse code in a window across the street. So just any kind of thing. It's really open-ended, and as long as it's somehow related to cybersecurity or encryption or something along those lines, we'll put it in there. And then so you capture that flag, that string of text, you come back and put it in the scoreboard, and that's where you get your points from. That also may unlock more difficult puzzles, because some of these are chained together where you have easier puzzles and they work you through harder puzzles. But it's a whole weekend where we get together on Friday night, all of Saturday and Sunday morning. We feed you delicious local food. Unfortunately, we make you hang out with a bunch of other stinky nerds like us, but you get to hang out with the community. You get to work with people. If you're in high school, you get to see some of the college folks, and maybe learn a little bit about what the programs are like at the college that you're interested in going to. If you're in college, you can see some of the industry folks and you can talk with them. Some of our sponsors will even send teams of folks to talk to you about what their jobs are like, and maybe put you in the hopper to have an interview or something like that. Many of these, especially we've had First Orion for, I think this is their second year sponsoring. They came and hung out with us the entire time last year. They got up, they spoke to everybody, and they sat and talked to folks about what kind of jobs they have. So I know they're interested in hiring some of the smart people to come in and be developers and system admins and business analysts and things like that. So it's focused on cybersecurity, but it goes beyond cybersecurity. So this program that we have, we're kicking it off tonight. This is the first night. We had a slightly different plans that we got a little bit of problems thrown into with some flooding in the tech park. So actually, Nick and I are remote. So bear with us if there's any technical issues there. But the first night is really about encoding in ciphers. And this is, things, if you've participated in JOLT before, you may remember some of Quasar's wacky ciphers that we pinned up on the wall and stuff that was hidden away, something you had to pick off the network and decode. So things like that, anything where you're taking a string of information and you're transforming it into some other means for some other reason, and how to detect that and how to transform that back into that flag that you need to get those points. And so Nick has been a great game master for the last several JOLTs, and he really brings a lot of that that encoding in ciphers from computer science brilliance, as he is the illustrious Reverend Doctor of Computer Science at ASMSA.
Not a doctor.
But maybe a reverend.
Not a maybe the spaghetti church, whatever that one is.
Yeah, in the Church of Computer Science. But Nick has really exploded this area, and I know a lot of you who have been there have either wanted to strangle him or you love him to death for having these great puzzles that really make you learn. So with that, there's at least 6 or 7 hours of slides here. I'm going to turn this over to Nick, so we're not here for another week.
All right. So yeah, as Chris said, encoding and encrypting is kind of some foundational skills that you need to approach some other puzzles. So there are a few puzzles that are specifically aimed at these, but a lot of the higher level puzzles, you'll need this to build on and then reach some other puzzles. but just in general in the world, computer science, there's a lot of encoding that goes, that happens, and encrypting that happens. And if you understand a little bit about how it works, it can open up some attack vectors. If you're a black hat, and if you're a white hat, it can help you, you know, figure out what you need to do. So anyways, I'm gonna start talking about encoding. And that's just basically like taking something like this message here, and figuring out how you can represent it in a different way. I typed out this message using my keyboard, and my keyboard has about 95 different possible symbols I can type. If you need to send it, you know, and you're only limited to, you know, 85 symbols or 64 symbols, then it's going to have to get mangled a little bit. And so you might have seen strings that look like this before, which just looks like, you know, somebody just keyboard mashed possibly. But this is actually the exact same message, just represented with only 85 symbols. And you can see here at the bottom, I kind of list out those symbols that are used: uppercase A, uppercase, lowercase, numbers, and then a smattering of other keyboard characters.
Nick, can I break in real quick? One thing
Yeah.
I forgot to mention, there's a Q&A function in here. If you have questions along the line, that's kind of while I'm here, I'm not just here to ramble on at the beginning, but drop a question in the Q&A, and I'll either answer it or we'll bring it up and let Nick answer it in front of everybody. Yeah,
if I say something that sparks a question, yeah, write it down. And if Chris deems it worthy, he'll interrupt me. We'll figure it out. I actually encourage you guys to ask questions.
Yes, please do.
So anyways, yeah, you can crime it down to where you only have 64 characters, and you get a string like this. And now you can see the character set's only uppercase, lowercase, and numbers, and then maybe a couple more. And then, Chris just put a poll up for your experience. Anyways, moving on. Anyways, you can have 32 characters, or you can have 16 characters, or you can have only 10 characters. Anyways, it keeps on going. You can use as few characters as you want. It goes all the way down to binary, where you just have ones and zeros. And as you can see, like as you go through these different ways to encode this, it starts getting bigger and bigger, and you have to use more and more characters. And so obviously, you know, when you want to send it somewhere, you want to use, if you want to like send it over the wire, you'd want to use the most efficient packing possible. But anyways, why do we care about encodings? So you can do really good at JOLT, right? or because you need to send something or store something, and you're at the mercy of whoever, you know, whatever medium you're sending it through, or whatever you're storing it onto. So the default encoding doesn't always work. Sometimes you have to switch to something else, and so you can just move data around. That's all that there is to it. So imagine that you want to store this onto a hard drive. You can't take the letter N or U or T, and you can't just stick that onto the hard drive by itself. Hard drives don't work like that. You can only tell them, hey, store a 0, store a 1. They only work in base 2. They don't know anything about actual characters. And so we have to figure out a scheme to like store things, just so we can use computers on a day-to-day basis. So give you guys a little history. Back in the 60s, you know, the American Standard Code for Information Exchange, they got together and they developed a table where they say, hey, this letter has this value. And you guys might have heard of ASCII before. Every single character has a number associated with it. And when you have that, then instead of like trying to put a letter onto the hard drive, you can try to put a number. But again, hard drives, you can't just say store 110. You have to work a little bit harder. So we can represent this in a bunch of different ways. You could represent, instead of base 10, the N is number 110 on the chart, wherever that is. You can see that's 110, but you can also see it has a hex value and it has an octal value. So there's all sorts of different number systems that you could use to represent this, and you could even represent it in binary. So we have just here, there's 4 different options on just how you can talk about these letters without actually using the letters. So one of my earlier slides, I popped up base 10. Just to be clear, there's a few different ways you could do base 10 encoding. This is probably the most common one that you would encounter in a JOLT or just practically in life. And so here you see a bunch of 3-digit numbers. They won't always be 3-digit, like the first one here is 84. So I just added a 0, so they're all 3 digits. But you might just get a string of numbers, and you can then just go look up on the table, see what letters there are, and you can read your message that way. Or you could do it hexadecimal. This one's a little different. Every pair, you can go look that up on the table and get back your message. And here is octal. Out, we got the results. 56% of you are novices, and I need to teach you teach you my ways. I'm down with that. We'll try that. And then we have no advanced people. So, and then intermediate. I hope I can teach you guys a few things, and I hope for those 6 that don't have any skills. I mean, you guys have skills, but those that say you don't have skills, I hope I can hope some of this helps and get you some skills at least. So, all right. So, anyways, and then we have binary. So this one has every 8 bits represent a character. You can, again, go look that up, figure out what number it is, and go look that up on the table. So this is kind of how it works. You have the letters, you figure out what number. In the case of a hard drive, you would turn those into 1s and 0s in binary. And in those, you can then go store on the hard drive. So a little aside, a set of 8 bits is a byte. I bet most people know this, and there's 256 possibilities, 2 to the 8th different values a byte can have. And just a little aside, if you guys look at the table, you'll see that there's 128 possible things, 128 possible ASCII codes. And the reason is they kind of built in the idea that you could have a parity check. So you could add 1 extra digit. So you only need 7 digits to represent the ASCII code, and then you can have an extra digit to tell you whether there's an even number of 1s or an odd number of 1s. So like this first one, it had 4 1s, and so you could put a 0 there to say, hey, it already has an even number of 1s. But this next one had 3 black 1s, and so you could put a 1 there to even it out. And if you're getting data from somebody and you go through it and you do the parity checks, you can see if those don't match up, and your data is garbled. There's some modern techniques that do a lot better error correction, like that can actually detect where the error is and fix it. And parity checks are still used a little bit, but not quite as much as they used to be. And so it's a lot more common now when we have data to like actually fill up all 8 bits with actual meaningful data and not have them reserved for parity. But that was something that was definitely very common back whenever ASCII was created. So even though using a byte to store stuff, we only get to use 7 of the bits. And then a short little history on bytes. Bytes were the idea that how much whenever you're processing data as a computer, like how much you're gonna eat at a time. So old computers, they could process, sometimes they'd process 7 bits at a time, or 6. Some old academic computers, they even had bytes as big as 128 bits. And so the size of the byte wasn't a constant thing. It just depended on whatever computer setup you had. And it wasn't until IBM came along in the business world, and they kind of like standardized it, and like it will be 8 bits. And so we started out with 8-bit computers, and the rest is history. And just a little aside, if you didn't know this is maybe one thing you can learn. There's a thing called a nibble, which is half of a byte. Not a joke. You can go look it up if you don't believe me. Right next to gullible, right?
That's legit.
All right, so back to my example. So I have these letters, and then I get those numbers, and then I get that binary representation, and then I can then go stick those onto the hard drive. The hard drive does speak ones and zeros, and so I can store that. So if nothing else, encoding is very important, just to be able to put something onto the hard drive. So anyways, the data can fit. So anyways, base 2. All right, so those, moving forward, there is a slightly different way to encode. What I was doing in the, up till now was every single character got changed into something else. But there are some other techniques where you can actually have, in this case, I'm gonna have 3 characters go in, and it's gonna turn into 4 characters. So the process here, I'm gonna take I'm gonna take each character, I get the ASCII codes, that's kind of a common flow for these. I'm gonna turn that into binary, and I have 24 bits here. And if I want to turn those into, if I want to turn that into 4 characters, I can chop it up into 6-bit chunks. So I can redistribute where the groups are, and then I can turn those back into numbers. And then there's a different table you can go look up. In this case, this is Base64 encoding. So they're going to use the uppercase letters and the lowercase letters and in the numbers. And so like 27 is going to go to a B, 39 is going to go to an N. Anyways, you just get, whoops. Anyways, you just get this, you get these 4 characters but those 4 characters only are going to have 64 possible options. So with 6 bits, 2 to the 6 is 64. And so this right here is Base64 encoding. So for Base64 encoding, just to reiterate, you're going to take 3 characters, do some slicing, dicing on the binary, and you're gonna poop out 4 characters. But those 4 characters will only use 64 characters, and they won't have any special like backslashes or time symbols or @ symbols. So it's a lot easier to send those somewhere. So if you have an email attack, if you want to send data in an email, you can Base64 encode something and then send it. So.
But Nick, before you get into Base64, we did have a question
Sure.
asking about the importance of at least understanding the ASCII code translations.
What's the importance of, let's see.
So the question is more of, what's the level of importance of understanding this table here?
Okay, you don't need to memorize it, but this table does underpin all communication worldwide. So anytime you want to, you're actually dealing with letters on the screen. If you actually so I have a file that has an F stored in it. If I actually go look at that byte on the hard drive, it's going to have 70 stored in binary on the hard drive. And sometimes you're going to get the data and you're not going to know that it's text. You're not going to know it's binary. So like knowing that values have corresponding letters is a very important concept. What do you think? Did that answer that question?
Yeah, no, I think that was Robert. And everything that we do to write these things is, as Nick has talked about, Nick teaches computer science. I have a computer engineering degree. He's talking about translating these still into numbers. When I think about how this gets stored on the hard drive, I'm thinking about those little magnetic blips on the hard drive, and you can magnetize a 1 and a 0. A 1 is magnetized, a 0 is nothing. Kind of like electricity on the wire. A 1 is a certain voltage above, 2.3, and a 0 is a certain voltage below, 0.5 or whatever it is now. And so these are how you write those yeses and nos into a location that can only take a yes or a no. And that's how we translate these into these specific characters. If you do some cybersecurity work, maybe if you're doing web app penetration testing or something like that, you may see some encoding like this in there in trying to prevent SQL injections and cross-site scripting flaws by encoding that document or that certain character in there, like a less than or a greater than or a semicolon or something. So you'll see this kind of stuff everywhere. So it's good to understand that that's some kind of translation to show you that there's a space here, or there's an underscore or something. And ASCII is just one of the sets that you can translate to. We use mostly UTF now, Unicode, but ASCII is the one that's just easy to teach, and it kind of makes the foundation of what is Unicode UTF-8 now.
Yeah, so there's just a little side, there's UTF-8 and UTF-16, and those are really an extension from the ASCII standard. So all these numbers still apply. So even if you encode something as UTF-16, you store a G on the hard drive, you're going to be storing a 71. But now you have the way to put kanji characters on the hard drive too, instead of just these very English-centric characters, right?
Yep.
All right. So, anyways, this right here is Base64, where you turn into binary, you split it up into other groups, and then you turn it back. And just real quick, you can do the exact same thing by splitting into groups of 5. And 2 to the 5th is 32, so you only have to use 32 symbols now. In this case, 5 characters is going to go to 8. So that's base 32. And then there is one other type, and I don't want to get too into the theory here, but the most dense encoding is ASCII, or is base 85, which is what I'm going to show you right now. And to do base 85, you take 4 characters, you get their ASCII values, and you turn those into binary. And in this case, I'm going to get these 32 bits in a row. I figure out what that number would be collectively. And then you do a process of dividing by 85 and modding by 85. Anyways, you get an expression like this where you can split it into 5 different numbers. The 5 numbers I care about here are 35, 42, 52. Anyways, you can get an expression like this. And so in this process, you can go from 4 characters to 5 characters. The process isn't super important, but this will give you, will let you just use 85 characters instead of all of the characters that you could ever type. And so,
and this was a puzzle. I think last year we had multiple encodings that you had to decode back through, and one of the encodings is base 85 because it's so wacky and obscure.
So yeah, this would be a pretty common thing to see in a database for them just storing data. Some databases can store in binary, but a lot of people instead just make it a string filled and then shove in base 85 encoded stuff, so they don't have to worry about configuring the database to handle binary information. And all right, so demo time, live demo time. So let's
cross fingers.
All right, so what's weird, I'm going to use Python, and I'm not going to spend too much time to make sure I go slow enough for everybody to catch everything. This will be recorded. I encourage you guys to download Python and try things on your own. So I'll start off by just saying, to do encoding, you need to import Base64, which does all the encoding, 85 and 32 and 16. So anyways, go figure. You import Base64 to do all the other ones. And whatever you do, Python is so powerful. Don't do this line. Don't at least run that line. So anyways.
You need to share your console window.
Am I not?
No.
Let me try new share. All right, can you see me now?
Hey, there you go.
I'm up.
Yep.
All right. So sorry about that. So I have to do encoding, you have to import Base64 in Python. I'm using Python 3 something. And just a little side note, like almost any language is good if you guys want to pick up something and start be able to script some stuff up. I feel like Python is one of the easier languages. If you guys don't already have a language, I would encourage you guys to pick that up. And I can do a surprising amount of heavy lifting stuff, even that I don't even have to go to C for with some specialized libraries. So I find it less and less every year reasons to have to go use C. So anyways, you would use Python's really slow, it's interpreted, but there's a bunch of libraries that are written in C. So we can just use the libraries and offload the hard work. So anyways, I'm gonna import Base64. I have this little message. And if I want to encode it, all I have to do in Python is say Base64 dot Base64, I want to say encode. We'll try that out. And we'll give it this message, MSG. And if I run this, I won't see anything. I have to print out what the result is. This is what I get for live demos. Is it a little... Oh man. Okay, now we go look at the documentation. So Python Base64 encode. I knew I should have left one line up there because they're all very basic. To do an encode, I say B64 encode, which is easy cheesy. All right, there we go. We got a Base64 encoded message. That's all you have to do for that. And if you want to do any of the other types, you can just say Base32 or Base16. There is not a Base8 in this option. I'll show you how that works here in a second. And you could even do Base85. So here you go. With a few lines of code, you can code whatever way you want. And just to kind of show you the other way around, I can copy one of these. And then to go the other way, I could base, in this case, I think I got a Base85. I can do a decode and I can just give it that message back. And I don't know why I'm hitting compile. I should get back, this is the test. So encoding and decoding is pretty straightforward in Python. You don't have to try too hard. There is this one little trick where you have to make a binary string for this to work. So that's just as easy as putting a B in front of your quotes.
That was actually a question. I'm going to jump in there real quick since Chris had to step away. That was actually a question someone had. They said, is the B before the string? This is a test necessary. What does it do?
Yeah, if I don't put the B in, it says, hey, I can't do it with a string. So in Python 2, a string was a binary string. So basically every character had a byte. But in Python 3, they wanted to be fancy, and you can put kanji characters or whatever you want in there. And so each of those characters might not be a byte. And so by putting a B in front of it, I'm just restricting it to just characters that represent bytes, which makes this encoding work. And you can go back and forth between things that are byte strings and those that aren't, but just in the interest of time today, I'm just gonna put the B in front of it and call it good. All right, there is one other Base685 encoding. There's actually two competing standards. There's the ASCII 85 and Base85, and they'll both look a little different. So here you can see, let me zoom in here. These two types are both 85 encoded, but they have different characters, and you could have any number of them. You can make whatever encoding you want, but those two are the standards. So that pretty much covers most all encodings that you might see out in the real world. And I'll kind of run through these for, like, when you see something, how would you know what it is? And so this first one, if you just see a smattering of like all the characters, you need to think 85. If you see uppercase and lowercase and numbers, you need to start thinking 64, Base64. If you're seeing it could be uppercase or lowercase in a few numbers thrown in, but not both uppercase or lowercase, then you probably have Base32. And that's not really used very much. I think they just left, I just taught it and just put it in there because it goes with the flow. But yeah, base 32 is not a very common one. This one is a common one. I happen to get no letters in this, but this one is actually base 16. And so these are all hexadecimal numbers. So if you see mostly numbers with a few letters thrown in, you know, A through F, then that's going to be hexadecimal. And if you just see a message, then that's just normal ASCII. So if you can read the flag, you found it. So anyways.
Now we're going to put something in that throws everybody off. That's not going to be the flag. We're going to find some sort of collision where, you know, base 64 becomes regular readable text.
So also as a little aside, I'm right now I'm coming from a string, but this could just as well come from a binary file. And so this doesn't have to be human readable as an input, but it turns it into something that can be sent in an email or stored in a database. And so if this was just a bunch of random bytes, this would work just as fine. I'm just using input string just to make it easy on me. All right. I'm going to continue on and I'm going to talk about the other types of encodings where you just take each character and you turn it into a number. And I'm just going to demo that with a real simple for loop. So I'm going to say for every letter in the message. And I'm just going to go through and if I want to, I can print the int version of the letter. So right now the letter is a byte. I'm going to turn it into an int so I can print it out. And you will see that here I just have a bunch of numbers. Those are the same numbers as the ASCII values of T, H, and so on and so forth. And just to make this where they print all in the same row, let's say comma end is equal to a space. All right, here we go. So here I have a bunch of numbers in a row that equal that would be my base 10 encoding. One approach to it. There's a few different ways, but this will be the main one.
But Nick, going back to the base 64, is there any significance to those equal?
Oh yeah, good point. And you'll see that there's equals on a few of these. If you remember back on my slide, I had like base 64, I had to have 3 characters and then it turned into 4 characters. And if you don't have a multiple of 3 characters in your input, then you have to have some filler. And so this is just saying, hey, they didn't have a multiple of 3, and so this output is not important. So if you actually count up how many characters there are here, or there should be there should be a multiple of 4. Let's see. Yeah. So there are, I can't count. But anyways, there's a multiple of 4 characters of what I've highlighted. So they just fill it in with an equal sign. So that's kind of a telltale if you ever see equal signs at the end of something that you're looking at some kind of encoding. And it's possible for them to be left off and stuff to still work. But typically most people just leave them on. So if you look at the end and you see equal signs, that should hopefully ring a bell and let you know that you're looking at, in this case, either base 64 or base 32. Base 84 also, you can have fillers. I think it's a different one. I forget off the top of my head.
Yeah. Another question too, is there differences in the different Python versions with that base 64 module? Because Adam said he doesn't have, or the base B16 encode and B32 encode works fine, but B85 doesn't seem to work for him. Do you know any off the top of your head?
I'd be curious if A85 works. I would be sure that these 3 would work, and I want to say some of these are deprecated. I can actually go look real quick.
Yeah, because typically you'll see it referred to as ASCII 85, at least when I've seen it. That's always the way I.
All right, so according to this, A85, ASCII 85 was new in version 3.4. I doubt you have a version before. If you have 3, I'm sure you have 3.4.
Well, you might still be using, yeah, new in version 3.4, but you might, if you ran Python on a system that still has Python 2, Python might point to Python 2.
Uh-huh. Yeah, so I just check what version of Python you're running.
Yeah, you might try restarting Python as Python 3.
Right, right.
I don't want to assume you're stupid, Adam, but that's the best thing I can think of right now.
Yeah, I wouldn't swear that these would always be there, but I think they should be. All right, moving on. Just to kind of throw down some quick ones. I can go through the letters and I can turn it into I can get the hex version of it, or I can get the oct version of it. I think that works. Or I can get the binary version of those. And so, no, this is printing weird things. Oh, I need to put some other for loops. Okay. So here we go. We have a few different representations. The first row, that's base. Oh, I need to put some prints between these. Sorry, live demos.
We did have one question. I'm not quite sure where it was, but the question was, is that the same as ORD? I'm thinking
Okay, yeah, so ORD's a good function. So if you have a non-binary string, you can take the letter and you would say ORD here. And that would get, I think ORD stands for ordinal, and just basically gets what number is it in the ASCII table. But since this is a binary string, it's a byte. And so this is already of a number type. And if I just make it commit by saying, hey, turn it into an int, it will. All right, so here we go. We got base 10 here. Here's hex. This is how Python just decided to show it with a 0x. That's kind of a common notation to say, hey, that's a byte, or that's a
hexadecimal.
That's a hexadecimal, yeah. But you don't have to have those. And here, I've never actually seen this except in Python with a 0 and then an O for the octal ones. And then the binary ones down here, they have 0B. But anyways, if you get a JOLT problem, those aren't going to be there. They'll just give you some binary or some octal or some hex, and you'll have to deal with it from there. But I just thought I would show you that, you know, hey, this message can be represented in all those different ways, and you can get back out. Here, I'll just do a real quick example here. Let me separate these with commas. That'll make my life easier. All right, so let's say I have this, I have that. All right, so if I have some numbers that you got on a problem and you want to go through and you want to see if those are ASCII values, you're like, hey, those look like they might be something. You can just, you know, loop through them, and you can say for number in nums. And then in this case, I'll print out the char, the character of that num. So it'll do the reverse. It'll take the number and then go to the ASCII table, and find out what character that is. And here, and I'll do this little trick so I can print them all side by side.
Yeah, and in Python, that's called casting. So if you guys do need to look that up, you're casting one variable type into another. You're forcing like an int value to come back as a character.
This worked as long as I have some prints in here. All right, so there we go. I got, this is the test at the end. So I just went from the numbers back, and you can do that any way you want. So if this happened to be like you happen to have like a string of these numbers, you might have to like first turn it into an int from the string and then go from there. So I guess it's worthwhile doing one more slightly more complicated one. So let's say you have the, heaven forbid, the base 8 version, the octal one. Let's go grab this string. Oh, I'm gonna cheat here. I'm gonna take off the first 2 characters. And I'll, all right, here we go. So here's the octal version. You'll notice that none of the numbers here are above 7. And I'm gonna take that number. So, so I'll say nums again, and that's going to equal all of that stuff. But I don't want to have those numbers in base 10. It'll interpret them wrong. I need to have Python interpret them in base 8. So I'm going to use a trick called split. So I can take a long string with a bunch of commas, whatever. I can split it on a comma. And I'll just print out nums real quick. Anyways, I just have a bunch of strings now with all the different numbers, and now I can go through them one by one and try to figure out and deal with them individually. So now I'm going to say for num in nums. And in Python, if you want to return a string into a number, you'd use the int command, and you can give it that num. But it has a really awesome superpower. You can put a comma here, and then you can tell it what base your input number is coming in at. So if you're coming in base 7, you can put a 7 there, whatever. This one, we know it's base 8 because we looked at it. We don't see any 8 9s or A's or B's. Anyways, so I would put 8 here, and I can get what my value is. And I'm going to print out the char of that. Let's see if it works. And it works. Huzzah. So that's about all I wanted to show on the encoding side and decoding side. Was there any questions I need to address, Chris, before I head on over to the Kahoot?
Yeah, there was, could you also use eval?
Yeah. Eval won't work here because it'll evaluate it as a int. So eval doesn't work here, but if it was a base 10 number, eval would work because it'll read it in as just a normal number. If this said 0, if it said 0, on all of them, eval would work because then Python could recognize them as octal numbers with that prefix. Were there any others?
That was it, man. You're good for Kahoots.
All right.
Let's go see who has the chops and who can stand 9cat the longest.
All right. So if you haven't already, I think everybody that wants in, I think has, but if go to kahoot.it, if not, and write down this number, because we're going to get started here in about 30 seconds. So if you have that number, you should be able to jump in midstream, I think. And we can play the music. Okay, that's all. I'll make you guys listen to that.
Oh yeah, we did that. We hacked the knock at FIS once and played that across all of their unpatched Windows XP systems up there. They loved it.
All right, so I'm about to get started. If you guys have never used Kahoot before, it's just on your phone. You'll have some 4 buttons that you can push, and on the Zoom screen you'll see the question, and you'll have to read the question, figure out what button to push, and then push it on your phone. You won't have all the information on your phone. You'll have to use both, and we're trying to go. You're trying to be accurate and fast. So if you want to get on the top spot, you need to answer quick. So anyways, I'm guessing this is probably new to some of you guys, since not everybody. This is really popular in middle school classrooms. All right.
500 knocks.
All right, we're going. I guess we're still getting a few people. All right, we're starting in 10. All right, here we go. All right, dead beef. What kind of encoding is dead beef? What likely encoding? right, base 16. You guys are doing good. So, so those that didn't get it, hexadecimal has 0 through 9, and then also A, B, C, D, E, and F. And programmers have been having fun with the fact that you can spell things with those 6 letters for a long time. So one of the most common things that we spell for whatever reason is dead beef. So Steve-O, followed by the Kiwi and KT. Here we go. What is this?
I hope nobody misses that one.
I mean, it could really be any of them, but all right.
Which one is it most likely?
All right, Steve-O's still on top.
Yeah, the quicker you answer, the more points you get.
All right, what does this look like? All right. That is actually base 85. I should give you points. So whoever got that wrong. So that was actually taken from base 85, but I forgot to get one that was more representative. So anyways, I apologize. Those that answered base 64, you should have gotten points.
The imaginary points. The points are made up.
Yeah. It's just for fame and glory, guys. All right, Tristan got thrown into the top. All right, here we go. What is this? Likely, what is it likely? Good job, guys. All right, got some mix-ups.
Oh, that was tricky.
Yeah, this one took me a second. And I made the quiz. All right, base 10 for sure, but fooled a lot of people. Yeah, so you can see an 8 in here. So definitely not octal. Since there's 3 characters instead of 2, then it's not hex. And so, yeah. Kiwi's back on top.
Just barely. And as you guys are answering this too, the Q&A questions that you guys are sending are really good. So keep those coming, and we'll keep throwing Nick off.
All right, this one was base 64, so I guess it fooled somebody. So what you're looking for is uppercase, lowercase, and numbers. And if you're not seeing too many symbols, then you can. If you're seeing symbols, you're thinking base 85. If you don't see symbols, but you still see uppercase and lowercase, then you need to think base 64. All right. Steve-O's back on top. Yeah, I apologize, Steve-O. I probably knocked you off with that second question there, but you made it back. I guess it's Stevie-O.
Stevie-O.
All right, good job, guys. Here's the winners. Adam K.
Rock.
C.S. Lewis. Man, he's still rocking it for an old guy.
Yeah.
Stevie O. Man. That's really close. So anyways, Stevie O, you get fame and glory. All right.
Internet points.
Internet points. All right. Control FN F5. There we go. All right. So I guess getting back into the swing of things, I guess I'll do a time check to see how much, what time do we have a hard time, or do we go until people start logging off?
You got about 20, 30 minutes for this one. So
All right. So
questions.
Am I still sharing my screen?
Yeah.
All
If
right.
you're not, I'm big in it.
I'm trying to.
Create the
All right.
presentation.
I can computer. Okay. So we're going to talk about encryption. So you know, if you go to JOLT, we're going to throw you some softballs, try to get you get your this is not really a practical computer science thing, but you know, we have the classic Caesar cipher where we just take the alphabet and we rotate it a bit, and you get a different letter. So a D would go to an A, an E would go to a B. You can rotate it however you want. Here's an example of what I call ROT13. Well, everybody calls it ROT13. So this is the classic one where you rotate halfway through the alphabet. What's really cool about this one is if you encrypt it once and then encrypt it again, you'll get back what you originally have. So encoding or encrypting it is the same thing as decrypting it. So it's kind of a cool one. This is you're bound to see these in capture the flag events as like just kind of get you going, even though they don't really have that much of a practical use in everyday computer science and IT. Anyways, just listing all of the different possible ways you guys could shift the alphabet. So there's like obviously 26 different ways that you could do it. So you might have a problem where they don't rotate 13. You might have something like this. So live demo time again. So if I grab that and I go to, we'll do this. And I have that message, I would like to get that message back out. So to do that, we need to figure out a way to rotate the letters. And so I'm going to write just a little for loop here to go through each letter and then figure out how we can add to it and like have it go around the alphabet. So I'm going to go for every letter in the message, and I'm going to do something with each of those letters. So first thing I need to do is I need to figure out where that letter is in the alphabet. So I'm gonna say index is equal to alphabet dot find the letter. So that will tell me where it is. So it'll tell me 0 if it's an A, 1 if it's a B, so on and so forth. So once I have that, then I can just say index plus equal however much I want to shift. I'll just make it a variable. Shift is equal to, let's just say 5 for now. So I'll shift it over 5. And once I have that, I might have gone off the end. I can solve that just by like putting another copy of this in here. That would be the hack way to do it. The cool way to do it would be say index mod equal 26, or the length of the alphabet if you have a different size alphabet. And so what that will do is if I divide by 26, what's the remainder? If you don't know what a mod does. And so if I was at like 27, it would bring me back to 1. And so just rotate me around. So now that I have all that, now I'm ready to print whatever the thing is. So I can print, I'm actually going to go back to the alphabet, and I'm going to use that index I calculated to go get one of those letters. And I'll run it that way. And I got that. And it also did spaces. I need to handle spaces a little differently. So if if the letter is in the alphabet, I'm going to do this, and else I will just print a space, print whatever that letter is. All right, here we go, bam. So here I have it rotated 5, so I got the message back. So I have this message which some unknown amount of rotation, and I just have to go through all 26. It's a pretty easy one to crack because there's only 26 possible keys, right? So I can, as a human, I can just go look at those. If I was a computer, I could go through and look for words that are English and just only show the results that have English words. But with 26, I can easily just look at them. So to help me out with that, I'm going to rewrite this a little bit. I'm going to have a string called output. Instead of printing it, I'm going to just add on that letter onto my output so I don't print every time. All right, so I'm gonna assemble this output, and then now that I have it written that way, I can encapsulate all of this into a nice little function called rotten. No, anyways, rotten, where I can give it a message and I can give it a shift. And so now I can just call this function and it can just do all of that for me. So now below that function, I can just do a simple for loop for I in range 26. Those that don't do Python, that might look a little weird for a for loop, but that's how you loop from I equals 0 all the way up to 25. And in this case, I'll print the rotten version of the message shifted I. So the very first, and I'll go ahead and label this. Let's say the string of I plus colon plus that. Okay, so I'm just I put a little nicety on here so it can print each number in the message beside it. And if I run this, it says I did something wrong. Okay, I need to return output. And there we go. So now I have all 26 possibilities here. And if you just scroll through there, you'll find one that says, how are you doing? I'm gonna guess that's the right one. So huzzah, we're crackers.
Rot 17.
We're hackers. We're hacking.
You have to say I'm in, and your most gravelly voice.
I'm in. So, all right. All right. So that's pretty much all for the Caesar ciphers. That covers all of those, and you're bound to see those if you go do any kind of capture, not just JOLT, any capture the flag events. They're gonna throw those in there to kind of get you going, get you hooked. So there is a, oh, I meant to change that out, but not this diagram, but there's substitution ciphers where you can have letters go to, you can have them crisscrossing however you want. So a D could go to any letter, there's just a one-to-one correspondence between letters. And that's just called a substitution cipher. A rotation cipher is just a subset of that. Substitution ciphers are quite a bit harder to solve. And you'll see them, I'm sure you guys have seen those cryptograms in the newspaper. I don't know, have you guys seen a newspaper? But anyways, in the newspaper, they have these sections where they print out the cryptograms. And anyways, the go-to for attacking those is with what's called frequency analysis. And so here is English broken down by what letters used the most. And you'll see that E is by far the most common, followed by T, and then followed by an A, and then so on and so forth. And so what you would do is you would take something that somebody's wanting you to crack, and you'd throw it in there, and you'd figure out what kind of well, first off, you can take some, like if this was a lot longer, you could take it and throw it into an analysis tool. There's a bunch online, and it could tell you what the distribution is. And if you're getting a lot more, like if you get that kind of distribution where there's a lot of one, a little bit less, and it just goes down to almost nothing of some of the characters, you might be looking at just a basic substitution cipher. And if it follows the same kind of trend that you know, English or whatever language you're speaking follows, then you just have to figure out what the correspondences are. And I'm not going to go write a substitution solver, but what you basically do is you go and you try the most common, followed by trying the next common. And since this one already has spaces included, you also know that these are words. And so you're going to go through all the 3-letter words, starting with the most common, and you're going to find all the possible, and you're going to find the ones that make words. And it actually is not too hard to crack something like this. With software. Who's going to do that by hand? So anyways, I would encourage you guys to use tools a lot, but for this one, if you just go into Google and type substitution cipher solver, I think this quip one, you can just throw it in there, and this completely ruins these problems, but you'll get it to crunch on it for a second, and it'll say the squirrel is a cute animal. Huzzah, I'm a hacker. So I point this out. I know that this is not like, it wouldn't be that interesting of a problem for Jolt to like just have something that you can go put in there and it'll solve what the substitution is. But this might be an intermediate step in a bigger problem where you have some numbers and you have groups of numbers, and then you have to turn those into unique symbols, but you don't know what number goes with what letter. You might just have a straight up encoding that's just using different letters, and you just don't know what it is, and you don't know their file format. You can use this to help solve for what the actual message is. So there's a lot of practical reasons that you might want to do a substitution cipher solver. But anyways, there's some really good online tools. There's some that you can download and run offline if you need to do something a little more heavy duty than this website will do. All right, back to this. All right, and then this one is this one's where we're getting into real stuff. The XOR cipher. This is the I'm going to do a straight up XOR cipher, exclusive OR cipher. This is kind of the cornerstone of all modern day encryption, except for the public key encryption. All the non-public key encryption is backed by the XOR cipher. So here I have some bytes. I'm showing you 2 bytes here, and the symbol for XOR is different, but in most languages it's the caret. So if you ever are trying to take something to the power and you think the caret's the power, you're going to get some interesting results. But anyways, if I XOR these 2 bytes, what an XOR does is if I have 1 in both of the columns, in both of the numbers for that digit, I'm going to get a 0. And if I have a 0 in both of them, I get a 0. The only way I can get a 1 is if there's only 1 between those 2 numbers. And so here I have 1 1, here I have 1 1, and here I have 1 1.
So real quick, so the XOR, the X is exclusive. So that means it's one or the other, not both and not neither. This is a big part of logic. If you're doing any kind of digital logic, you've got all of these, the and, the not and, the or, the not or, the XOR, the not. And these are all the things that your computer and the processor uses to do adding and all of the functions that are done on these on the information that you have put into the computer. And that's another reason from at the very beginning where Nick said, if you want to store this somewhere, you can't just store an A, you have to store it in a ones and zeros format. And that's also because when your computer does that arithmetic, it's doing these kind of exclusive ORs and ands and ORs and nots to actually do your adding and subtracting and multiplying and dividing and comparing.
Yeah, nice. And with the XOR cipher, whenever you have 2 bytes and you XOR them together, you get another number. And so like you can imagine one of these as your message and one of those as your key, and then you get an encrypted message, or your crypttext. And then if you XOR it with that same key again, if you take your crypttext in that key, then you're going to get back the original message. So it's this really cool symmetric thing where you just apply it once and you get it, you get the encrypted message, and you apply it again, you get the decrypted message. It's kind of like the ROT13, but more sophisticated and useful. Now you can have as many bytes as you want in the key. And if you don't have enough bytes in the key, then you can just repeat the key over and over again until you get the length of the message. That's the most common way to do an XOR cipher. And it may seem like since I'm saying this is the cornerstone of a lot of our modern day encryption, it wouldn't be necessarily the one you would want to use, but it's actually incredibly secure if you're using a key that nobody else knows. So let's say you have, you wrote a book that you just shared with one other person. You can use the text from that book as your key. And as long as nobody else gets that book, nobody else will be able to read your message if you encrypt with the characters from that book or whatever. So the security of XOR is all dependent upon how secure your key is. Nowadays we have more modern encryption with public key encryption where we can share the keys, and that has some benefits. But if you're able to share a key and make sure with somebody else remotely and have it where nobody else gets it, this can be incredibly secure. So whenever you do XOR encryption, a lot of times you might get some values that are outside of the normal ASCII range. And so it's typical that you're going to represent stuff in hex, or it'll just be in binary. And so here's a message where the key is squirrel, and I have my, this is my crypto text, and I have to figure out what that message says. So I'll head on over to a live demo, and I'm trying to get to it. Okay, here we go. So I already went through and put in all those numbers. I put 0x in front of them, so Python knows those are all hex numbers, so I don't have to worry about that. And I have the key squirrel. And so what I'm going to do is I'm going to loop through every combination of my number from the message and my letter from the key. And Python has this really cool thing called zip, where you can just zip up the message and the key together. And so, so here's a thing with items, and here's a thing with items. I can just zip them together and loop through them together at the same time, which is kind of a neat thing. So that now that I have the number and the letter, I can XOR those together. And if I just put a B in front of this, I can literally just print out num caret letter, and let's see what we get. All right, I'm getting some numbers. And I'm guessing 114 is a valid ASCII value, and I can go look it up, and then we have 97, but we want to turn those ASCII values into actual numbers or actual characters. And so all we'd have to do that is put the CHR function around it, and it'll go look it up for me. And I get race cars. So I was trying to find something that was 8 characters long. So had to add an S on it. So what's really cool about this is I told you it was reversible. So I can now use my message and I just change out the key and I'll get back squirrel. So it can go back and forth both ways. And again, if I have a longer message, then I can just make the key longer by just repeating it over and over again and going through them together. So anyways, super common cornerstone of encryption here.
Now, if you look up any encryption algorithm, AES, RC4, something like that, they're going to, if you look up the actual algorithm behind it, you're going to see a lot of XORs in there in multiple iterations of XORs.
Mm-hmm. So yeah, I just plopped in, I don't even know exactly what encryption scheme this is, but it's common that you take a block of plain text, and then you split it up into chunks, and then you permutate them. So here you can see a network of what byte goes where, and then and then you see the key. You have key 0, key 1, and you have these circles with crosses through them. Those are XORs. And so you do this permutation and XORing, and permutation XORing, and if you know what all these rounds are, you can actually undo all of this. And that's, I mean, it's not good unless you can undo it, right? Because then you could never decrypt it.
That's called hashing.
Right. So, so anyways, this is, so using the XOR concept with some extra sauce, we get something called a block cipher. And there's different levels of block ciphers. There's some where, so basically it doesn't encrypt the whole message, it just does little blocks at a time. That's why it's called a block cipher. And there's some block ciphers where every block is done independent from the others. And that has a fatal flaw, because if you have the same text in multiple places with the same offset, it's going to encode them the same. Or if you have a bunch of, like, you know, white pixels or something in your image, you're going to get some repetition in your blocks. And you can actually, like, get a lot of information about what is in the message. So there's some pretty straightforward attacks you can do if you know it's a block cipher. But there's some where this block is going to change how the next block is going to get encrypted, which will change the next one. And that one's very secure. There's still a few different ways you can attack that, but that's going to be beyond today. But I do have
real quick.
Yeah.
I have one question. Go back to that picture. The question was, does it break up the key into 4 parts?
Yes. Typically, I don't know. I actually don't know which one I grabbed here, but yeah, typically you're going to take your key and break it up into parts, and then apply those different parts at the different stages. So good question. All right, so I set up this little website. Let's see if I can get to it, called Encryptomatic. So what this does is I can type something in, and what it does is it's, this was a previous challenge, but when you type something in, it gives you the message encrypted. And it's using a block cipher. It's actually using ECB encryption. So if I just type a bunch of numbers, well, if I just type in a bunch, you'll start seeing this interesting thing where I'm getting the same block over and over again. So it's using that insecure type of block cipher where if you have the same block somewhere else, you'll get the same thing. So even though it's really hard to, you know, figure out what the key is and crack it, now that I have a window into it, I can if I'm attacking to somebody and I want to see what the extra encrypted bit is, and they're encrypting it for me, I can, since I get to control what I'm putting in, I can help figure out what the message is. So let's see. But I'm gonna, before I get into actually cracking this, okay, so whenever I add this 0, I get another block. And then whenever I add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, I get another block. So, so with that little bit of information, what it's doing is it's taking 16 characters at a time and turning those into a block. So with this information here, seeing that I have 2 blocks down here, I know that I have over 16 characters, but less than 32. And if I add some characters here, let's see. So if I add 6 characters, it just barely fits in here. So according to that, if I do math, 32 minus 6, I actually can't do that math in my head right now. 26, yeah, 26 characters in the message. So anyways, I know information now. Like that's what this is all about. Like taking, trying to extract a little bit of information at a time. So let's go back until I get that first one. That's so this is what. So if I have 16 zeros, I get this block. So if I take away 1 0, now I have this block is the encryption of all zeros plus 1 character from the message that I want to extract. And the question is what that is. And well, maybe not 100% obvious, but if I type a character in and this doesn't change, then I got the right one. So if I'm at JOLT, then I'm thinking maybe this is a flag. So you might try something like an F, which, huzzah. doesn't change it. So with or without the F, oh, it has to be uppercase F. Okay, it doesn't change it. So I now know that character is an F, right? And now if I delete one more character, this is going to change. Or let's see. Yeah, if I delete one more character, so this is that message plus whatever the next letter, well, this is what the first two letters are. So I can put an F and L here. Let's see, F, sorry, F. So if I put an FL here, I see that my block starts with D to C, and if I don't have them there, I still get D to C. So I'll just kind of jump ahead. I'm gonna assume this is like flag with a curly brace, and so that starts with a 582. If I don't have that, it also starts with a 582. So I'm gonna stop here. I'm not gonna continue cracking it, but this is very close to what we use for encryption nowadays. And as you can see, if somebody's not smart on how they set something up and they allow you this window into what's going on by actually encrypting something for you and giving it back to you, you can actually get information. So anyways, that pretty much brings me to the end. There is a website called CryptoPals, which I'll go to real quick. If encryption is interesting to you and you want to get better at it at a level that's actually useful, then this website I would highly suggest. They take you through some real basic stuff, and then they get to high-level public key encryption and these block ciphers. Take a look at this. They have some really good curated set of problems, and it's really well known in the cryptography world. So there's a lot of people that have done write-ups on these and have code out there to help you with all these things. So CryptoPals, I can't recommend it enough. If you really want to get good at encryption, that's the website for you. So with that, are there any questions, Chris?
You have answered all the ones that were in there throughout the thing. If anybody has any kind of closing questions, feel free to drop them in there now. We'll banter on and breathe loudly here until somebody does. But if you do have any, kind of wrap up questions, please feel free to drop them in there. So
while we're waiting for some questions to come in, I really hope that those that haven't participated in JOLT, do come participate. It's a lot of fun. You will learn way more than you ever imagined in such a short amount of time. Like you get these every time you solve a problem, you get like a little, I don't know, dopamine hit. It's kind of addictive after a while.
Yeah. So we do have one question in there. First one, why are other bases not included, say a base 53?
So, all right, so let's get to the bases. Okay, so why not a base 53? And that is mostly because of, let's see, where do I have the binary? All right, sorry, here we go. All right, so basically most of it comes from, you turn it from characters into binary. And once you have it in binary, then you slice and dice it up again. So if you take 7 characters at a time, then that would be base 128, which is pretty much just ASCII to begin with. So you wouldn't use that one. If you take 6 characters, that's base 64. So all of these are base are powers of 2 based, which is why there's only 8 and 16 and 32 and 64. But you probably noticed that there was this one. This one was base 85. And why 85? Like, that's kind of a weird number. Well, the reason is whenever they made base, well, I don't know if it's because of when they made base 64, but when 64, leaves some characters on the table. So if you want to send a message to somebody using as many characters as you're allowed to send, say in an email, then you have more characters than just 64. So we want to use more characters. And so we already know that if we're sending bytes, we can't just send that byte because it might be a value that's not on the ASCII table, because we might have like a byte might be 255 and and that's not on the table. So we have to do some kind of encoding. So if you actually look at this, when you have a group of, let me bring up a calculator. If I have a group of 4 characters, you have 256 possibilities for each one of them. Let me go to a scientific one. I have 256 possibilities for each of them. If I go to the 4th power, I have 4 billion possible values I can store. So this number here in the middle can be up to 4 billion. And so with 4 characters, I have to have 255 possibilities for each of them if I'm using bytes as my input. So if I want to just expand it a little bit to 5 characters, then I need to take the 5th root of this and see what I get. And so if I take that to the 0.2 power, I get 84.4. So basically this is just kind of a math thing. If each of these can have 85 different possibilities, if you figure out like that's the smallest number of characters I can use to represent all the characters I need to. And so I'm sure they tried with like taking different sets of bytes and different numbers, but this is the one that is pretty much the best. It's the densest. It is a little bit more expensive on the calculation side, but only just a little bit. All right.
Okay, so next question, Wes asked, any word on date for JOLT yet? If you have a crystal ball, please tell us. We are kind of waiting out the situation to see what's happening. We're shooting for March, but we do not, we're not willing to stake our flag and say that COVID and everything is going to be done by then. So we're shooting for March. When we talk about it, we say March or April or May. So just stand by. We'll have you some information as soon as possible. Next up, Sean asks, what kind of skill level would you recommend for JOLT? Absolutely a great question, man. Walk in there not knowing a thing. If you don't know a thing, you will learn. Don't be afraid. That's the biggest part. I've seen people that will shy away from it because they're afraid that they're not going to, that they're going to look bad or they're going to, feel bad about it. I throw an example. We had a group of young girls from an after-school Girls Who Code program, and they had a great facilitator teacher in that, Shantae Moy. She brought them in, she helped them. It was a great learning opportunity for them. I remember very specifically, I had a puzzle that used floppy disks, and it didn't go so well because people were looking for actually trying to open the disk and find the flag on the magnetic part of it. But I remember the young, I think she was 12, and Shantae said, I'd like to take a picture of her with a floppy disk, but she's never seen one of these before. And immediately I felt like I was 100 years old. But just to see as they were like getting puzzles, they did reasonably well, but they weren't anywhere near the top. They kept trying, they stayed there, they learned, they were excited. They got that, what Nick said about that little dopamine shot whenever they'd get whenever they'd clear a puzzle. So, come in here, if you don't know anything, you will leave knowing something at that. Brian, to answer your question, absolutely not. You can come as an adult. Like I said, we have, when we first started, we had probably 90% industry teams from different companies. And over time, we've gotten more of the college teams and the high school teams. I saw Karma O'Neill, I can't remember your last name, Karma. Where are you? Karma Turner. I keep thinking Karama Neal. But Carmen Turner has brought a team many times from Lake Hamilton, and we have loved seeing her team come. And she set a great example. And I think last time we had 3 other high school teams come. We've had teams like from UALR come, and then since we've had the Conway group, Skylar and Wes that were on there, we've had a great showing from them last time with their brand new cybersecurity club. So it's just grown over the years. But Brian, I mean, grab a team of your guys at Blue Cross Blue Shield and come in. I know you got more people there. But you are an odd one, but I'll give you that. but yeah, you're the perfect person to bring some folks in, and sit down and just get in there. Matthew, to answer your question, it really, online is not an option for us because so much of what you get out of this is by being there in person. Another great example, about 3 or 4 JOLTs ago, we had a team from the Air Force training course out at Little Rock Air Force Base come through, and they blew everybody out of the water. I mean, they were just racking up points left and right, and they were thousands ahead of everybody else, and they just stopped. They stopped solving puzzles and they started walking around and helping people. And to me, that is the epitome of what JOLT is that community aspect that you just don't get from having an online CTF. And we really work hard. Ashley and her team at the Venture Center works hard to get like really good food in there and make the space very just very welcoming and very group oriented, which is why we can't do it now, because we don't want to leave. We don't want to have a COVID hotspot. We definitely don't want to be on the governor's briefing the next week. But so much of it is just that community aspect of it. And if you can't tell, I'm really passionate about this. It's a great program. I stumbled upon it after leaving FIS and starting my own company and getting involved in the Venture Center. And I'm very glad I did as a game master, because you get to see it from a little bit different angle. But there's people that are brand new to technology, and there's people that have been doing this for 20, 30 years, and they come and they work and they learn just as much as anybody else learns there, no matter what your skill level is. You'll walk away with new friends, you'll walk away with new contacts, and you'll walk away with new knowledge. Sure thing, Matthew. All right, so I think that is all the questions. I'll wrap up a little bit here. Ashley, can you pop up that preview slide for the next ones? So we'll have more of these as we go forward. We try to make them different times. So this one's a Thursday evening, the next one's a Friday lunch. We wanted to make sure that people had the opportunity to show up, kind of depending, whatever their schedule was. The next one is actually me, Josh Baugh, and Tommy Haycraft doing attack and defend puzzles. So this will be a little bit more on, if you get a puzzle that, says, hey, here's an IP address, what do you do? How do you solve kind of those, where Nick has told you, if you see this, then think this encoding mechanism, or if you see this, think this cipher. We'll go through there and talk about attacking systems. We'll have some PCAPs, which is network traffic captures, and how to use different tools to go through those. And we'll also hopefully be able to demo some defend puzzles or some defend concepts that Josh and I have been wanting to implement in these JOLT CTFs for a while, but it's just there's a lot of work to it there. So after that, Nick is back on with web vulnerabilities. We've had quite a few of these where we're just hacking into different web instances and web servers and applications and things like that. I think that's Nick and Tommy, I believe. And then finally, on October 30th, we've got Ben Allen, our newest game master, is going to show you some and demo some reverse engineering puzzles, which are going to be really cool. And just, kind of as an aside, if you win at Jolt enough, we tell you you can't play anymore and you have to come back as a game master, which is exactly how Nick and Ben both became game masters. We got tired of them winning, and so we wanted them to come make puzzles too.
And Chris, just a little correction. Ben's helping me with web vulnerabilities.
Okay, I wasn't sure if that was Tommy. Thank you, man. Yeah, so yeah, you get a double dose of Ben. So, and you get like a lot of doses of me, but I'm just kind of the Vanna White, the very ugly Vanna White for this. So if there's not any more questions, Ashley, do you want to wrap up for us?
Absolutely. I don't know where I went for a second. Thanks so much, everybody. I'll keep it brief. As Chris mentioned, we have 3 other sessions that you can be a part of, so be sure to register for those. Again, whether you're able to attend it or not, go ahead and register. You'll get the recording afterward, but we would love for you to attend in person. You can ask your questions, and also let's keep the conversation going. If you've got those questions, utilize that Discord channel that's in the chat. Maybe we drop it again one last time in the chat. I think most of you guys are there. So go ahead and use that and reach out and ask questions and keep the conversation going over on Discord. One last thing before we go. Big thank you again to our sponsors, Simmons Bank, the Little Rock Regional Chamber, Frost PLLC, Mainstream, Wright Lindsay Jennings, Euronet Worldwide, as well as First Orion. Thank you so much to all of those sponsors, and thank you so much to our game masters for giving your time up and being willing to put this on and help folks that want to learn more about Jolt and bring these tools and things into their professional lives, hopefully. So thanks so much, everybody. If there's nothing else, hope to see you again at the next session on October 16th. Have a great night. Thank you.